Welcome back. This is video 2 from Ms. Sanders' chemistry class. Today we're going to be talking about molar mass, but before we do, I want you to flip back to page 145 and make sure that you've done your Cornell note revisions, questions, and summaries for that page before we move on. Okay, what you're going to need today is your periodic table from the back of your notebook. I suggest you just flip it up so you can see what I'm referring to as we work through molar mass. So let's write at the top of our page today's essential question. How do you convert from moles of a substance to grams of a substance? And once again, these notes are going to go on page 147. So I want you to think for a moment about what takes up more space, a mole of marbles or a mole of bowling balls. Now, this is hard for you to think about because it's such a big number. Think about just one marble versus one bowling ball. And I hope that you can see that one bowling ball takes up quite a bit more space than one marble. All right, let's say you had a dozen bowling balls. Would they take up more space, or would a dozen marbles take up more space? I hope again that you said bowling balls. Now think about a mole. Remember, 6.02 times 10 to the 23rd. A mole of bowling balls versus a mole of marbles. And I hope that once again you see that a mole of bowling balls is going to take up more space. All right, try this one. Which has more mass, a mole of bowling balls or a mole of marbles? I hope once again that you see a mole of bowling balls it has more mass than a mole of marbles. So this is the case for elements on the periodic table. Some elements, like hydrogen, have only one proton, one electron. They're relatively light. They don't take up much space. They don't have much mass. A mole of them is going to be quite a bit less than a very heavy element, like, xenon, for example, 100, which has 54 protons, 54 neutrons, 54 electrons. It's quite a bit more massive, and it takes up quite a bit more volume. So we have a unit called molar mass, and molar mass is a measurement that is in units of grams per exactly 1 mole of that substance. It's substance dependent, meaning that every element on the periodic table has a different molar mass. We find it from the periodic table. It's not something we have to memorize. The only thing that you have to understand is that the units are grams per mole, because on the periodic table it just says a number. It doesn't say anything about the unit. All right, so look at carbon, number 6 on the periodic table. Right below the C, you'll see 12.01 grams per mole. So what's that saying is in a mole of carbon, it'll weigh 12.01 grams. So if you have 1 mole of carbon atoms, of which I mean you'll have 6.02 times 10 to the 23rd individual carbon atoms, that would have a mass of exactly 12.01 grams. And that number is unique to carbon. If you have a mole of anything else, it's going to have a different mass. So look to the number just below the chemical symbol on the periodic table. Carbon was our example. We're going to stick to about 2 decimal places in this class. Remember that it'll be that number, whatever number you see here, 12.01 in the case of carbon, will go into grams per 1 mole of that element. So in this class we're going to stick to 2 decimal places. I know some of these go out as far as 4 or 5 decimal places, but 2 is sufficient for what the calculations we're doing. All right, so think about a mole of hydrogen atoms. What is the mass of a mole of hydrogen atoms? 6.02 times 10 to the 23rd individual hydrogen atoms. Well, according to this idea of molar mass, 1 mole of hydrogen will weigh whatever that number is. So find hydrogen on your periodic table and look for the molar mass number directly below the H. I hope that you found 1.01. The 1.01 is grams per mole of hydrogen. In this case, we're asking for a mole. So the answer is 1.01 grams. 1 mole of hydrogen weighs 1.01 grams. All right, let's try it for xenon. Find xenon on the periodic table. It's all the way to the right-hand side. It's a noble gas. And tell me, if I had 1 mole of xenon, what would it weigh? So I hope that you found 131.29 right below Xe. 131.29 grams would be equivalent to 1 mole of xenon atoms. Well, let's go the other way. If I had 32.06 grams of sulfur, sulfur is S on the periodic table, do you see that its molar mass is 32.06? That means 32.06 grams for every 1 mole of sulfur. So the answer is 1 mole. All right, let's try one more. How many moles of gold in 196.97 grams of gold? So you look at AU, look for AU on your periodic table, that's gold. And I hope that you see that gold's molar mass is 196.97 grams per every 1 mole. So the solution is 1 mole. 1 mole of gold will have a mass of 196.97 grams. All right, so one of the things we're going to be practicing when we come back on Thursday is figuring out the molar mass of a compound. Remember, a compound is a type of molecule that has lots of different kinds of atoms in it, more than one kind of atom. So it's actually really simple. This is one of the easiest things you'll do. You determine how many of each type of atom, and you'll do that using the subscript or the implied subscript of 1. You'll add the molar mass of that atom basically as many times as it appears in the compound. All right, so let me tell you what I mean by this. Let's look at the molar mass of water. We all remember that water's formula is H2O. There's 2 hydrogen atoms and 1 oxygen atom. So I want to add up the molar mass. Remember, I just get this 1.01 number directly from the periodic table. This is the molar mass of hydrogen, right below the H on hydrogen's box. Make sure you can see where I'm getting that from. So I have 2 hydrogens, so 1.01 plus 1.01 plus the molar mass of oxygen, which is 15.9994, but we're going to round it up to 16. So the molar mass of oxygen plus the molar mass of one of the hydrogens, the molar mass of the second hydrogen, and the final molar mass of water, H2O, is 18.02. But don't forget, you have to include grams per 1 mole of water. So what this ratio means is that if I have 1 mole of water, it will have a mass of 18.02 grams. All right, let's try oxygen gas. Oxygen gas is O2. How would I sum up the molar mass of oxygen gas? Well, I need to take the molar mass of 1 oxygen, which is 15.99, but we're going to round it up to 16. 16 for the molar mass of 1 oxygen, 16 for the molar mass of the second oxygen. All I do is add them together, and I get 32 grams for 1 mole of oxygen gas. In other words, if I have 1 mole of O2 molecules, it's going to weigh 32 grams. If I have 6.022 times 10 to the 23rd oxygen gas molecules, it's going to weigh 32 grams. Now when we come back on Thursday, we're going to be doing some conversions between grams and moles, moles, grams, atoms, molecules, particles. Make sure you have all this written down and ready to go so that we have all the information we need to practice. All right, you don't need to do revisions, questions, and summaries for the notes that we just wrote down. We'll go back and review those on Thursday. But don't forget to finish up your lab, or at least be 99% done with it, so that I can check you off and we can print it out and turn you in on Thursday. Thanks a lot for watching. I'll talk to you soon.